Welcome to The Explainer. So, today we're jumping into a story that honestly sounds like it came straight out of an alchemist's wildest dream. Now, you've probably seen this one pop up online somewhere, right? Scientists discovered a bacteria that poops pure gold. I mean, come on. That is a perfect headline. It's an attention grabber for sure, and it promises this biological gold mine that's just out there for the taking. But here's the thing. While that headline is, let's be honest, total clickbait, the real story is actually way more astonishing. It points to a scientific reality that's just so much more elegant and remarkable than some meme could ever capture. All right, so let's get into it. First things first, we need to separate the viral myth from the actual incredible science that's going on here. So, you see the hype, right? Bacteria pooping gold nuggets. But the science? It's not about that at all. It's not about excretion, it's about survival. What we're actually looking at is this incredibly complex, elegant defense mechanism, a way for this organism to protect itself from an environment that would kill pretty much anything else. Okay, so let's meet the microscopic superstar at the heart of all this. This is an incredible little microbe that does something amazing. It thrives in places where you'd think nothing could survive. It's called Cupriavitis metal literans. Now that name, it literally means metal enduring. And that's your first huge clue, right? This thing has an astonishing ability to live in these super toxic, metal-heavy environments that are lethal to most other life forms. So, the big question is, how does it pull off this magic trick? How on earth does this tiny organism take something so dangerous and turn it into solid, pure gold? Well, the key is survival. This bacterium can't just sit there and take the toxicity. It has to fight back. And a really important study back in 2009 laid it all out. To stay alive, it has to actively convert this super toxic, dissolved form of gold, gold chloride, into harmless, solid metallic gold. And it does this with what you can only describe as a microbial fortress. It's a brilliant four-step defense. First, it tries to block the toxic gold ions from even getting inside. If some do get in, step 2 is to bind them up so they can't do any damage. Step 3, it has these tiny pumps that actively push the toxins back out. And for the grand finale, if all else fails, it transforms the toxin into inert, solid gold. It literally neutralizes the threat by turning it into treasure. And this is a really big deal. I mean, this discovery is fundamentally challenging what we thought we knew about geology. For centuries, the story was simple. Gold forms from heat and pressure deep in the earth. End of story. But now we're seeing that biology, tiny little microbes, might actually be a key player in how some of our planet's gold deposits were formed in the first place. That's a huge shift in thinking. Okay, so this isn't just a cool scientific fact. This unique ability, it opens the door to some incredible real-world applications. We're talking about tackling some of our biggest environmental problems. Let's just take e-waste, for example. Every single year, we create a mountain of this stuff. We're talking 50 million tons. It's a huge toxic problem, but it's also an untapped resource. All those old phones and computers are packed with valuable metals, including gold, that mostly just ends up in a landfill. And that's where this idea of biorecycling gets really exciting. Imagine this. Instead of using nasty chemicals like cyanide to leach out metals, we could use these bacteria. It would be a greener, lower energy way to do it. You could potentially set them to work on our mountains of e-waste, or even old mining tailings, turning these huge environmental liabilities back into valuable assets. Okay, but before we all get too carried away planning our micro-powered gold mines, we need to pump the brakes. There are some major hurdles between this amazing discovery in the lab and a real-world working solution. The biggest one? The yield is just tiny. We are talking about nanograms of gold. A nanogram, that's a billionth of a gram. So for making gold from raw materials, it's just not even in the same ballpark as traditional mining. It's nowhere near economically viable right now. And yeah, the tiny yield is just hurdle number 1. When you look at what it would take to scale this up for industrial use, you run into a brick wall of other problems. You've got massive engineering challenges, huge costs, and a really important safety concern that we absolutely have to talk about. And this isn't just some what-if scenario. This is real. A 2016 report in the Journal of Clinical Microbiology documented the first known case of C. metallodurans causing a serious bloodstream infection in a hospital patient. So, yeah, it's an opportunistic pathogen, and that's a huge red flag. You can't just go around spraying this stuff on e-waste heaps if it can make people sick. But even with all those hurdles, even if we never build a bacterial gold factory, the discovery itself is what's so important. It forces us to just think differently about the world around us. It's one of those discoveries that just blurs all the lines, between biology, geology, and even technology. It's a really powerful reminder that nature's solutions are often way more ingenious than our own, and that there are these hidden biological engines that have been shaping our planet for millions of years. So maybe the real gold here isn't the metal itself. The real value is the question it forces us to ask. How might this tiny bacterium change the way we define what a resource is, or what waste is? Could it help us shift our thinking from just digging stuff up and throwing it away to a more circular, sustainable way of recovering what we already have? It really challenges us to find the value in the things we're so quick to call trash.